So on the next slide, we are going to put a link to this simulation for you. But I wanted to kind of talk to you a little bit and show you how it works because we'll be asking you a couple of questions about it. So in the middle here, we can just, we'll assume that's our sun, and there we are, that's the Earth. And we can start it, and there we go. And we can see that we're going into an orbit. There we go. Come back around. Pause. Okay. And if you look at this, you can see that it's not a perfect circle. It gets pretty close to being a perfect circle, but it's not. It's just a little bit more egg-shaped. And so this is what we refer to as an ellipse or an elliptical orbit. Now, the reason that it's an ellipse is because we've got a combination of things going on here. Now, remember, the Earth would really like to just keep going in a straight line and not be bothered, right? It's got inertia and it's going, and we can turn on our velocity vector. And you notice it would like to just go in a straight line. It would. But gravity steps in. Remember that there is the force of gravity also there. Get it there. The force of gravity. Now, this is showing the force of gravity of the sun on the Earth, pulling this direction. They do not include the fact that according to Mr. Newton's third law, there's also an equal and opposite force that is pulling in the opposite direction on the sun. But remember, the sun is so much more massive than the Earth that, you know, the effect is not anywhere near the same. You can, there's might be a little teeny, might not even be able to measure wobble created there. But obviously, it's the interplay between these two things that cause not only planets and moons and other satellites to orbit, but also affect the shape of the orbit. So I'll start it again. You can kind of watch and you can see, okay, something is happening. I want you to watch carefully the size of the arrows. Remember, the size of the vectors tell us about the magnitude. They tell us how strong the force is, or how the speed of the velocity over here. And I want you to watch those vectors carefully. So you should be able to see a pattern. Watch again. What is happening to the size of those arrows, and when does it happen? Okay. And again, you'll be able to do this for yourself in just a minute. So I also wanted to reset this. This word eccentricity refers to how far away from being a perfect circle this thing is. And so I will tell you that comets have very squishy, very elliptical orbits. Okay, so I've really increased the eccentricity on this thing. So let's turn my vectors on. I like to watch those. Now look at this. Now you can see that there's a pattern. You can see when the gravitational force, remember the vector for the velocity is showing you direction and speed. So when the arrow gets bigger, it is showing you that the object is speeding up. Now, when you are looking at the simulation in a minute, one of the questions we're going to ask is, what is happening to make it speed up? Okay,